Hi everyone. In this video, I'm going to explain about logical operators and as well as bitwise operators. So first let us discuss about logical operators. These logical operators are the operators used whenever we want to check more than one conditions or whenever we want to concatenate more than one conditions. See, whenever we want to check any conditions, what we are using, so we are using either greater or lesser or equal to or not equal to, greater than or equal to, less than equal to. These are the possible 6 conditions what we can check. See, that means whenever we have two numbers, let us say A and B, so A and B, so run all the possible, I can check whether A is greater than B or A is less than B or A is equal to B, A is not equal to B, A is greater than or equal to B or A is less than or equal to B. These are the only possible things we can check. But here I am checking only one condition, whether A is greater than B, that's it. Here I am checking only one condition, whether A is less than or B, that's it. That means in each one I am checking only one condition. But there are some situation may come, so in which we need to execute or we need to check more than one conditions. Okay, suppose assume I want to check whether A is greater than B and as well as A is greater than C. So at that time, suppose see A is greater than B, okay, and A is greater than C. If both the conditions are true, if both this condition and this condition is true, I can say A is greater. Okay, so that means here to check two conditions, then only I can check. So for that means I need to check both conditions. So that way I am using ampersand, double ampersand. This is called logical AND. So this operator we should read it as logical AND. So this is the logical operator, one of the logical operator. Okay, so this logical operator used to check more than one conditions. So here this is one condition, A is greater than B I am checking, and this is another condition, A greater than C. These two I am combining, I am checking both using this operator, logical AND operator. Okay, so we have to use 2 ampersand. Don't use space or comma in between the 2 ampersands. So just ampersand, immediately one more ampersand. So this operator we will call it as logical AND operator. Similarly, we can use another logical operator is logical OR. So logical OR, we are using this as a pipe character. So this is 2 pipe characters. So this is again, so let us say whether A is equal to B or A is equal to C. I am checking. That means here I am checking whether A is equal to B or that is these two similar numbers are there. That means whether A is similar to B or A is equal to C. So that I am checking. Say here anyone. See, in logical AND, this is called what? This is called logical AND operator, and this is called logical OR operator. So you know that AND gate operation. So what is AND gate operation? Suppose if you are having two variables X and Y, okay, or A and B, okay, output, okay, both are, okay, see again, so in the logical operators always the result of the logical operator is either true or false. So I explained about it, the comparison operators also called as relative operators. Whatever the output of this comparison operator results either in 0 or 1. If the condition is true, it will be replaced by 1. If the condition is false, it will be replaced by 0. That we already discussed. So if I say if both are true, okay, see if it is both are true, then only the output is true. If any one is false, output is false. This is in case of what? Logical AND operator. Similarly for OR operator, if the two variables are there, then again if both are true, same thing, both are true, one is true, another is false, so both are false. If both are true, output is true. Anyone is true, output is true. Output is false or 0 only when both are what? False. So this is the property of what? OR gate. Okay, so same thing. If this one both are true, then only the overall result of this is true. If any one is true, then overall result of this is 1. If any one is false, overall result is 0. If both are false in this case, output is 0. Okay, so this is what logical and logical are. Okay, one more operator we are having, so that is logical not. Okay, so logical not operator, so this is the symbol is not, this is exclamatory symbol, and then only one variable. Okay, so now I will say not a. That means whatever the value a, so if it is true, not a becomes false. If it is false, not false becomes 0, not true. Okay, so this is what logical on. Only there are 3 operators in logical. There is one logical and, logical or, logical not. Okay, so let us see with the code how this will works. See, I have written the program. I declared 2 variables of integer type a and b, and then clear the screen. So enter a 2 number, just a message I'm printing. So then I'm reading the 2 integer values, ampersand a, ampersand b. I'm reading 2 integer values. Then I'm printing a greater than 0. The condition I'm checking what a greater than 0. A greater than 0. If it is greater than 0, what happens? The result is 1, true. So not true is false. Okay. Let us execute this one. I execute this one, enter any 2 number asking, but is only 1 is enough. See, first number I will enter 12 for A, and second number I will say 23. Okay, so the result I am getting what? 0. Why the result is 0? Just wait a minute. So just I will remove this one. Only one number is enough. Enter any one number. Okay, so now I enter only one number. I read one number that if the, suppose that number is greater than 0, what happens? Condition becomes true. So the true, not true is what? Complement is false. So I should get output 0. Okay, so let us check this one. So enter your number, say 1, simply 1. Okay, let us check 11. Now 11 is greater than 0, true. Since it is true, what happens? So condition is true 1, not 1 is 0. I'll get 0 now. See, I'm getting 0. Okay, now let us run the same program once again. So now I will write, say, minus number. I'll give some my negative number. Minus 2. Minus 2 is greater than 0. No, false. False means 0. Not false is what? True I should get. Okay, so next output I should get 1. Okay, 1 I'm getting. So why I'm getting 1 here? See, I get a value minus 2. Minus 2 is greater than 0. False. Since false, it will be replaced by what? 0. Not 0 becomes 1. That's why I'm getting 1. Okay, so this is how logical not operator works. Let us see how logical and operators work. So I already written the program. Now I declared 2 variables. I read the 2 values through scanf. So I am printing only one value. My condition is I am checking a greater than 0, logical and b greater than 0. If both are greater than 0, then only both the condition is true. Then the overall result is 1 and 1. That is what? True and true. The first row, 2 and true is true only. So I should get 1. If any one condition is false, output should be 0. Okay. Let us check this one. So I read the value. A I will give 11. So B value will give 22. Now both are greater than 0 or what? Yes, both are greater than 0. So that is 1 and 1. I should get output is 1. So I got output 1 only. Okay, see, because a is greater than 0, true, so it will be replaced by 1, and this is also greater than 0, true, 1 and 1. Okay, that's what I'm getting. So now I give any one as 0 or negative number. Let us see what happens. Now a value I'm giving minus 1, and b value I'm giving positive only. Okay, 12. Now here a minus 1 is greater than 0. No, false. If any one of the condition is false. See, next to 3 next to 3. Okay, any one is false, output is false. False means what? 0. Now I should get what? 0. Yes, I'm getting 0. Okay, this is how logical AND works. Similarly, now let us see how logical OR works. For logical OR, so pipe, double pipe, so logical OR. So now again, So if it is both are 0, both will be true, or any one is true also. If you see here, this truth table, if any one is true, then also output is true. Both false, then only output is false. Okay. Now let us see, I will give in such a way that all combinations are checked. So now, so this is first number, both are greater than 0, true, both are true means output is also true, so output should be 1, I'm getting 1. Okay, so next again, so I will check it. So now one first number given 0, second number some number, first one is greater than 0, false, false means 0, second one is greater than 0, yes, true, so 1, 0 or 1, 0 or 1 means what, 1 only, again I should get 1. Okay, now I will, instead of first number 0, now I will get second number 0. Okay, now first I give some number, then second some minus 4 I will give. Now first number is greater than 0, yes, true, true means 1, second number is greater than 0, false, 0, 1 or 0, 1 or 0 is what, 1 or 0 is 1 only, again I should get 1. Okay, now I will get both are 0 or lesser than 0. Okay, so now I will give one is 0, another one is say minus 3. Now first one is greater than 0, false, 0, minus 3 greater than 0, false, both are false, false and false are false, again false only, so output I should get 0. I'm getting. Okay, this is how logical OR works. Okay, these are the only 3 logical operators, logical and logical OR and logical NOT. Hope you people understood. See, always this logical operator output is either 1 or 0. Other than it never gives any other output. Okay. And this logical operator operates on the whole value of the numbers. See, I give some A value 10, B value to minus 12, 12, 20, minus 4, minus 5. So on the whole number it operates. Okay, so which one? Logical operator. Now again, so in completely all numbers, including negative number and positive number, all number is considered as what? True. All numbers are considered as what? True. Only 0 is considered as false. Anything other than 0, everything considered as true. Only 0 is considered as false. Okay. Now let us see bitwise operators. Bitwise operators are the operators. Again, these are also the binary operators, operates on the 2 operands. But this bitwise operates not operates on the whole value like logical operators. This bitwise operator operates on the individual bits of the number. Okay, so hence the name is what? Bitwise. That means it does not operates on the whole value like logical operators. So since logical operators operating on the whole value, the result of the logical operator is either 1 or 0. But here we make it whatever. Okay. So always bitwise operator operates on the individual bits of the number. Okay. Let us take some examples. Okay. Fine. So now let us take A value, say 7. Okay. So B value, let us take some 11. How to write 7 in binary? See, 1. How to convert this decimal number into binary? You remember this one. 1, 2, 4, 8. Next is 16, 32, 64 like that. So now I want what? 7. For 7, see, for 7, if I add which number here, you'll get 7? 4 plus 2, 6, 6 plus 1, 7. So you make those numbers as 1, these are 1, remaining is 0. Similarly for 11, if I add which numbers will get 11, I will get 8 plus 2, 10 plus 1, 11. Okay. So if I add 8, 2, 1, then remaining is 0. So this is the binary equivalent of 11. So now what I will say, now A is 7 is equal to what? Using 4-bit representation. So this is 7 in binary and this is 11 in binary. Now what I have to do? If I say, so which are the binary bitwise operators? So bitwise operators are what? Logical and so this is called not logical. We are using what? We are discussing bitwise. So bitwise and you should read it as bitwise and see difference is for the logical and we use double and. double ampersand. Now here it is single. If you single, it is bitwise AND. If you use double, it is logical AND. Similarly, single pipe, this is called bitwise or so, and this is called tilde. Okay, this is called bitwise complement or not bitwise complement or bitwise not gate not operator, and then so this is called right shift operator, this is called left shift operator. See, just the directions. So direction is what? See, if you use single, it is greater. So double greater is what? Right shift. Similarly, so direction is left side. Okay, so it is left shift. Okay, these are the bitwise operators what the C supports. Now discuss one by one. Now with this value, now if I say A and bitwise and B. That means now I am not operating on this 7 and 11. I am operating these individual bits. Now again, 1 and 1. So 1 and 1 is what? 1 and 1 is 1. 1 and 1 is 1. So 1 and 1 again 1. 1 and 0, 0. 0 and 1, 0. Okay. So this is the result. Actually this is equal to what? This is equal to 3. So that means if you do bitwise on A and B of this 11, I will get 3. This is the result. Okay. Let us see same thing by executing the program. Close it, huh? I declared two variables A and B, and again I am reading the two values at the runtime using scanf. Just I am printing A and B single ampersand, that is bitwise A and B. What I should suppose if I read A is equal to what? A is equal to 7, B is equal to 11, then I should get what? Answer is equal to, I should get 3. Let us see whether I will get the same or not. Okay. So I executed directly. So what is the value I given? A value 7 I even given, and then B value 11. So what I should get the value? Yes. So 3. So 3 I am getting. Okay. So this is how bitwise AND operator works. Now let us see how bitwise OR operator works. So bitwise OR is single pipe character A or B is equal to what we will get. Let us see. Now 1 or 1 what? 1. 1 or 1 again 1. 1 or 0 1. 0 or 1 also 1. So this is nothing but what? See, this is all of one sum means what? 8 plus 4 12. 12 plus 2 14 plus 1 15. So this is equal to 15. So this is what I should get if I use what? Exclusive, not exclusive, bitwise OR. So now I am using A bitwise OR. So this is A or B, same thing. So now I will run this. No errors. So now again I will give same value 7 and then 11. See, if I give 7 and 11, okay, what is A or B value? I should get 15. Let us see same thing I will get or not. So I read the value same 7 and 11. So now I will enter. See, I am getting 15. So I am getting the expected answer. So now let us see how bitwise not works. Okay, so now let us say A is equal to 7 and I am getting this value 3. Okay, for simplicity I will take, let us take 6 or some even simple values. Let us take 3. A is equal to 3 I took. So for what 3, which are the numbers? 2 and 1. So it is binary equal to 0, 1, 1. Okay. Now this is what 3. Now if I say not bitwise not, okay, bitwise not A. So bitwise not A means, see, just use bitwise not A. Individual bits will get complement. In place of 1 it becomes 0, in place of 0 it becomes 1. So 0 becomes 1, 0 becomes 1, 1 becomes 0, 1 becomes 0. Now this is what value? 8 plus 4, 12. Let us see, I'll get the same 12 or not, or something else negative number, that we will see. See, I declared only one variable for because this is a unary operator as well, because it is operating on only one operand. See, because it is not a, that means the not operator is operating on only one operand. So I need only one operand. So I am declaring only one variable a, and then I'm reading that one value. So using scanf, and I'm printing what? Not a. So bitwise not. Okay. So then I saved it. I check for the errors, no errors, and I execute. Now enter any one number. So now what is the number entered? 3. So for 3, what we are expecting, I should get, see, leave the value 12, but I should get what? 1100. That is the main thing. 1100 I should get. Okay, don't worry about the 12. Okay, we won't get 12. I will explain what is that. Okay, so I should get 1100 for 3. So now I will enter. See, I am getting -4. Why -4 is because, so in number representation in binary, so always the MSB bit, see, this is the MSB bit and this is the LSB bit. Always MSB bit indicates sign. Okay, whether you use sign and magnitude, whether you use ones complement representation, whether you use twos complement representation, whatever you use, but the MSB indicates sign. When I change this +3, it becomes 0. To now it becomes minus only. That's why I'm getting -4. But we don't know about -4. Okay. So how to verify this is -4 only correct? See, because I'm getting the answer what? -4. We saw. Okay. We saw here -4. Right. So why it is -4? Because -4 I'm getting whether this one only correct or not. So this -4 we don't know. But we know what? We know only +4. For +4 what? +4. 0, 1, 0, 0. Now for this you take ones complement of that. So 1, 1, 0, 1. This is the ones complement. Now add 1 to this plus 1. You add 1 to this, 1 plus 1, 0. Carry is 1, 1 plus 1, 0. Carry is 1, 1 plus 0, 1, 1. So this is what we got. So that is nothing but this is equal to -4. Same thing we are getting. Okay. This is how bitwise complement. In simple, so bitwise complement or bitwise not operates on the individual bits of the number and converts each one to zeros and each zeros to ones. That's it, bitwise complement. Okay, now let us see how right shift and left shift operator works. Okay, now let us see a is equal to 3, same value. A is equal to 3. Now let us see left shift. Left shift means each bit is shifted towards, see, this is my right, this is my left. Each bit is shifted towards its left by 1 positions. Okay, so this 0 will comes and sit in this position. This 1 comes in this position. This one comes in this position. So by that, so this 0 comes. So this 0 comes in this position. This one comes this one comes here. But what about this vacant field? Always the vacant bit will be filled by 0. This is what the, after that means I shifted how many times? One time. So before shifting, what is the value? 3. Now this is equal to what? This is equal to, see, which are this one? See, 1, 2, 4, 8, 2, 4, 6. Now this is equal to 6. Okay, so that is after shifting one time. What I shifted? I shifted. Where I shifted? Towards its left. So A left shift. How many times it shifted? 1. So this is how to write. The meaning is this. A is left shifted one time towards its left. Okay, this one. The value of the 3, I'm getting 6. Okay, so let us check through the program. See, I declared one variable, again same thing. I read the value of a through scanf, and I am what I have to shift a left shift. Okay, left shift means lesser than, and I am shifting how many times? Only one time. Okay, only one time. So that's it. I check for the error, no errors. So then I executed this. So what is the number I entered? 3 I entered, right? 3 entered. So what I should get according to our explanation, for 3 we should get what? 6, right? So let us see whether we are getting 6 or not. Okay, so if I enter, see, I'm getting 6 only. So exactly it is working. Okay, now suppose if I left shift one more time, what happens? Let us take, so instead of A, that means now it get 2. That means what is the meaning of this? A is left shifted 2 times. Okay, A is left shifted 2 times means, so what I should get? Let us check the answer. Then I will explain. So again 3, it's left shifting twice I'm shift. Okay, so I'm getting 12. Okay, that let us see through the explanation. See, now I left shift one time here, so 3 becomes 6. Now I'm left shifting what? 2 times. So that means now again what? This 0 comes in this position, this 0 comes in this position, this 0 comes in this position. So what happened? So I got this as 1, this as 1, this is 0. Again the vacant position I need to fill by 0. Now this is equal to what? See, 1, 2, 4, 8. 8 and 4, 12. So this is nothing but 12. This is what I got here, 12. So after left shifting twice. Okay. So I left shift twice. So I got 12. See, one time I left shifted, 2 times I left shifted, 12. So this is what A is, if you left shift by 2. Okay, I got 12. So in general, left shifting means multiplied by 2. See, earlier 3. One time I shifted, multiplied by 2. One more time, again multiplied by 2. One more time, again. If you shift one more time, I will get 24. Okay, so like that, every time you left shift once, it will be multiplied by 2, equivalent to multiplied by 2. So this is what left shift operator. Similarly, exactly in the same way it is in the reverse order. If you right shift towards its right by one position, so the bits will be go and fill the next position towards its right, and the vacant bit will be filled in between 0. Okay, let us say same thing. So now I'll take reverse or take. Okay, now instead of 12, I will take the 12 only and let us see what happens. So now A is equal to 12, or let us take say 16. Okay, for 16, see, if I add all these things, 8, 4, 2, 1, not 15, but I need for 5 bits. For that I need 5 bits. Okay, so for 5 bits I need, so 1, 0, 0, 0, 0. This is what 16, because this is what your 1, 2, 4, 8, 16. Okay, 16 only one, remaining all are 0. Okay, now let us see. Now I'm shifting what? Only one time towards its right. That means what? This one comes here, this 0 goes here, this 0 goes here, this 0 goes here. So that means I will get what? This one be shifted here, this 0 comes here, this 0 comes here, this 0 comes here, this 0 went out. Okay, right. Now again the vacant bit, always vacant bit we are filled with zeros. Now this is equal to what? Now here what? 1, 8. So this is nothing but 8. Okay, so now what we did, towards its right by one position, I got 8. Similarly, one more time you shift here. Now this 0 comes here, this 0 1 comes here, this 0 comes here, this 0 comes here, this 0 went out, and vacant bit I filled with 0. Okay, so for your reference, I'm writing this 0 comes here, this one comes here, this 0 comes here, this 0 comes here. Okay, now this is equal to what number? 1, 2, 4, only 4 is 1, so this is nothing but 4. This is nothing but 4. Now what we did, we right shifted A 2 times. Okay, let us check the same. Again, I declare the same program, only one variable, read through the scanf. I right shifted what? See, A, I right shifted towards right by one position. So, if I read 16, I should get what? If I right shift by one time, I should get 8. If I right shift twice, I should get 4. Okay, so let us see that one. So now I will execute this. See, entering one number, what the number I entered? 16. See, 8 I am getting. I have shifted what? One time. So let us shift twice. Instead of 1, so what I did, I shifted twice. A, I am right shifting twice. So I should get what? Since I did changes, I checked for errors, no errors, I executed. So again we get 16. So I should get what? I should get 4. It says I am getting 4. Okay, this is how right shift works. If you observe, say right shift, for original value of the number is 16. If you right shift one time, so 16 becomes 8, half. Again, if you type one more time, 8 becomes 4. That means right shifting. Okay, right shifting towards one position is equal to divide by 2. Similarly, left shifting the bits towards its left by one position is multiplied by 2. So this is simple. See, if you're coming by this way, 1 becomes 2, 2 becomes 4, 4 multiplied by 2. If you go like this, 8 by 8 to 4 divided by 2, 4 by 2, 2, 2 by 2, 1. So like that, if you move towards right one position, it is divided by 2. If you left shift towards left one position, it is equivalent to multiplied by 2. This is what the bitwise operators. Okay. So now we discussed logical operator and bitwise operators. The difference is always the logical operator result is either 1 or 0. That depends upon the condition is true or false. So we are using logical operator only whenever we want to check more than one conditions. And always logical operator operates on the whole number. Okay, whereas bitwise operators operates on the individual bits, and we may get the results. Okay, we may get whatever the results based on the values of the variables. Okay, here we are not getting always 0 or 1. Okay, so bitwise operators we are using whenever we want to do operation on the individual bits of the operand. Okay, or the number. Okay, this is what bitwise operators works. Hope you people understood. If you have any questions, please write into the comments. Thank you. Thanks for watching.